Okay, I think this slide the last time. Maybe over Christmas time you'll think about what it means to be a college student. Tomorrow we're going to finish up the balsa wood. How many people have missed the balsa wood aircraft preparation? 2, 3, okay. On Monday, there's going to be a quiz, and it's going to include everything we talked about this week in the history of aviation. So whether they are notes that are up on the board or whether they're things that we talked about or I talked about, they're both going to be available on the quiz on Monday. Yes, it is an open note quiz. And some of you take very, very, very good notes. And with the notes that I've seen, I wonder why you don't get 100% on every quiz. Okay, any questions about this particular slide that we talked about the last time? One of the reasons that the gentleman who went to 9,000 feet never went again is because it turns out that he scared himself so badly. Apparently it went up so rapidly to 9,000 feet, so rapidly to such a great height that he scared himself of that. I can appreciate that. I mean, back then, going up at all off the Earth's surface was something phenomenal. It's hard to imagine the feeling that people had in those days about aviation, because it was brand new, 1783. People were all of a sudden scrambling to do new things, and there were always those people called daredevils. We've had those in our society, not only here, but in all kinds of industries, like rocketing. Everybody ever remember a guy by the name of Evel Knievel? He was kind of crazy, right? I mean, he talked about jumping the Snake River Canyon. He didn't make it, did he? But he was a daredevil, and he was one of those people who was pushing the envelope of the kind of things you could do with a motorcycle. He didn't do it. Guy will turn on the propane. The flames are pointing up inside the balloon. You'll see that. I have a slide to show you. the balloon lifts off, to me, ballooning is so much more dangerous. I would say maybe skydiving is number one and balloons are number two, because you have no control of them. And there are so many accidents in the United States in balloon flying, because once you go aloft, the only control you have is what? Up and down. That's it. You drift with the wind, and if it turns out that for whatever reason the people who were forecasting the windy conditions got it wrong, you went up when it was calm, and now you're up there 15 minutes, and now the wind is blowing 40 miles an hour on the surface, how are you going to get down safely? The answer is you're not. You're going to come down, and you hope you're not going to injure too many people. If the wind starts blowing when you're up, it's really difficult. It means somebody's going to get hurt, probably. Because as you come back down, you're going along the field. You're getting blown across fields and fences and gates, maybe even structures like barns, things like that. One of the reasons why the Balloon Fest is done in Albuquerque, New Mexico, is because they have flat desert land surrounding everything. Andrew, would you do me a favor? Would you go sit in the back of the room for the rest of this presentation? So, the big problem is that here in this country, and there was actually supposed to be some sort of a Clovis Balloon Festival that was going to take place this weekend. I don't know where they're going to load up the balloons. Oh, sure they do. There are strong winds everywhere. It depends on the conditions. It depends on whether the forecast is good. I know that balloonists are completely at the mercy of the weather. Where? In Albuquerque? Well, sure there are mountains. There's Sandia Mountains, number one. But if you are east of Albuquerque and east of that mountain range, you're out in a flatland that goes for dozens and dozens of miles. So you can go up reasonably safely. And if the wind does start blowing, you can come back down. You'll be dragged across the desert floor until the guy who's operating the balloon can get rid of the hot air inside. But ballooning is not a lot of fun. I mean, it's really interesting if you can guarantee that the weather is going to be nice and calm, and you can go straight up and maybe come back down straight. But that's not normally the case. Normally the case is that a balloonist has to hope that some morning early he thinks maybe the wind will be calm for a few hours, and then they run and they morning hours. And why do they do it in morning hours? Because you get a jump on the day, right? But more importantly, because it's really cool, and so it doesn't require as much propane being blasted into the balloon to start lifting off. Then as the day heats up, they need more and more propane to burn in order to keep the balloon aloft. But today they don't use helium, they don't use anything, they use hot air, and hot air is with propane. You'll see that in a minute. I'll show you a picture of heating up a balloon. You remember Mr. Charles? He was a very famous guy who, along with Robert Brothers, had developed balloons in France. Maybe that we've already completed this slide. I'm trying to guess about where we left off, and I think it's around here, or just before this slide. And feet, scared himself, and never went up again. The fact that so many things occurred rather quickly in 1783. Just an amazing thing that went on at that time. This is the hot air balloon that I believe is resting in, and I don't know the name of the museum that it's in. The netting is the thing that or held the cab. Parachuting. It's kind of an interesting subject along with balloons, but balloons have been used to parachute. Talk about the world record for the jump out of a balloon. Again, he was from France. France is another, that's one of those countries that continues to do great things in aviation early on, and you can see why they continue to believe to this day that they are the seat of aviation worldwide. And that was in 1797, just 14 years later, after the first balloon ever went aloft. Here we are dropping parachutes, dropping things, and jumping out of balloons that soon afterwards. And that was how many, that was 220, almost 221 years ago today that happened. That's a long time, and it's certainly a long time before the Wright brothers ever established powered. What else besides powered? What kind of flight did the Wright brothers become famous for? What were the attributes of flight? Pardon? What? Steerable. That's correct. Powered, steerable flight. Powered, steerable flight. Okay. Same thing. Sorry about that. There's a picture of Mr. Gagarin in his balloon. In his parachute. Balloon with that parachute. But it's interesting because it's a basket parachute rather than being strapped on. But you'll notice that he is tethered. In this particular picture, it doesn't show it, but one of the pictures shows a tether from here on up into the canopy, where in addition to this, he was actually, I guess it was maybe an emergency tether. What the word tether means, by the way? Attached. Tether means attached. T-E-T-H-E-R-E-D, tethered. Okay. We did talk a little bit before about military balloons and their use, and the people who designed and developed the first balloons were ultimately very much saddened by not only the balloons, but also by the airships, the blimps, the dirigibles, the airships, because they were used very, very quickly for war, for killing people. Again, in France, Napoleon's army used the first balloon. They used it as an observation platform so Napoleon could see what was going on the other side of a hill. Machine. Gun through the propeller, and they didn't want to have the gun pointing to the side. Almost impossible to aim a gun if it's pointing to the side and you're flying this way. They ultimately figured out how to do that, how to time the machine gun so that the bullets would go between the propeller blades as the propeller blades were going around. But before that, they were blowing off propellers. In those days, the propellers were wooden, right? So a couple of machine gun bullets would destroy a wooden propeller. Then that imbalance practically tears the engine off the engine mounts. Because of the imbalance, and it's spinning, and the engine is constantly jerking to the point where I believe probably people ultimately wound up losing an engine because it got torn off the airplane. This is a good example of it. So most of the ballooning was done from the standpoint of exhibition. That was done for a couple of reasons. To show everyone this new thing called ballooning, and individuals wanted to show people what they could do with ballooning. Interest investors in giving them money so that they could develop even more advanced, complex balloons. And it got to the point where balloons sort of morphed into a blimp, then that morphed into a semi-rigid airship, then that morphed into a rigid airship. And that's what we have today. We have rigid airships that are completely maneuverable and steerable. But in fact, it takes a lot of time for airships. For instance, for example, that I flew frequently go up to Seattle, and it takes forever for that thing along the mountains on its way up to Seattle. Very often we at Apple, doing our glider operations, we'll see a blimp go by, and it just takes forever to get by. You can see it in minutes as it goes slowly along the mountains. There were some long-distance flights. There were people who wanted to do their best to outdo one another. There were some flights from Albany, New York to New York City. There were flights attempted across country. There were flights that were attempted to the Arctic Circle. There were flights that were attempted multiple times to go over the North Pole. No one succeeded until a blimp from Norway finally made it, but maybe we'll have a picture of that here later on. A man by the name of Wellman, W-E-L-L-M-A-N, he tried almost, I believe, 4 separate times to fly over the North Pole. He kept getting closer and closer, and finally he just gave up because I guess he couldn't get any more money. One of the people in the current modern day, a man by Capilani, and in that book he sort of judges Wellman pretty harshly by saying he didn't really have the guts to continue on with some of his attempts at the North Pole. So he gave up. Eric? Pardon? Yeah, there was a body found. Who was it? Amund or Roland? Amund Rolandson? Roald Amundsen, right? Yeah, because apparently he was searching for a crash. He was searching for a crash of another balloon, and he disappeared. Sure, just like there are on Mount Everest. You guys know anything about what happens if you climb Mount Everest and you die? Because fragile white marble. It looks like white marble. Your body freezes, so if you go up next to a corpse on Everest and you want to, let's say, lift that corpse, the hand breaks off. Just breaks off. It's like a piece of candy. The arm breaks off like a piece of candy. The whole body would just ultimately shatter into pieces if you tried to move it. So some of the very, very famous people who climbed Everest are still up there. And they're the people who pay for going up there have to walk past some of these bodies. You know, they know that they're there. They know they're going to have to walk past them. But you can get on YouTube or you can get on anything on the internet, and you can look up Mount Everest dead climbers, and you can see all the photographs you want to of these dead bodies laying there in different states of repose from having died up there and being left in the same spot. You can't move them. First of all, it's too dangerous to try to bring a body down the side of a sheer wall, right? And that Everest being 29,036 feet, it's a horrendous climb and it's a horrendous descent. When I went to Nepal, for me, going up the Himalayas was easy compared to going down. In fact, when I fell, I actually fell on a very steep descent. And that's the only time that I felt like I was really in danger, was going down instead of going up again. So there are funny things go on when you're mountain climbing. Trekking, but in the Himalayas, everything is vertical practically. So the first military attack in 1849 with bombs, Austria versus Venice. So when you see that word first, that kind of means that you might see that on a quiz, huh? First this, first that, first parachute jump, first hydrogen balloon, first balloon ever. First use in warfare. Balloon, first use in warfare. Who was that? We just talked about it, right? Napoleon? Recall? A couple of minutes ago? We had a picture of Napoleon's balloon. And in our own country, the Civil War. You know a little bit about the Korean War and World War II. You know a little bit about the war. So let's say you talk about the Vietnam War. In the Vietnam War, how many Americans died in the Vietnam War? 1,000, right? And in the Korean War, it was probably not that. The Civil War was the most costly war in America. When you compare that to the Vietnam War, to the Iraq War, to the Afghanistan War, to the Korean War, to World War II, just 4 years, 1861 to 1864, right? That was the Civil War. Anyway, this happens to be a picture of a Civil War balloon called the Intrepid. I have no idea what battlefield that was used on, but it's just an example of the fact that, yes, indeed, we were using it to help kill one another. One major record you be one, yes. What else, Mark? Yes. Happens. What does a balloon look like if it's going to go up to the stratosphere? What does it look like on the ground? It's probably a tiny little thing, right? Maybe from a distance as big as my fist. But when it gets up to altitude, what does it look like? Gigantic. Because it continues to expand as it goes up. So the higher it goes, the bigger the balloon gets. Hopefully we'll see a picture of that. Here's the kind of balloons like that all day. That mountain range that runs just along the east side of Albuquerque. But, you know, there's not a lot of room. And here they are filling a balloon, and you can see the two burners. Okay, Susan. What do you... Because I don't trust. They know for sure. While if they want to risk themselves, that's fine. But for me, I'd rather fly an airplane that where I go and when I land. So they're filling this bag. And that wasn't done too long ago. Before you were born, of course, but from my point of view, not too long ago. Called the Double Eagle. The distance achieved around the world in a balloon. Hard to believe. The bright moved their race venue from so from the standpoint of the quiz, these are kind of hot points, aren't they? And listen, look when that was achieved, only 2014, 5 years ago. The highest human parachute jump ever, 100. Are you saying Red Bull is what now? It could have been. I'm not sure, but it could have been. Let me see if this is worthwhile for us here. It might be. These are just pictures of so there is the balloon on the ground, just taking off. You can see how tiny the top of that balloon is. But then when it got to 106,000 feet, it turned out to be a gigantic balloon in terms of size because, of course, the differential of pressure between the inside of the balloon and the ambient air. And here he is jumping from above 100,000 feet.
What did they do with that balloon after he jumped?
Pardon?
What did they do with that balloon after he jumped? Just let it go?
There he is when he... You know, if you guys would rather talk, why don't you step outside? You can talk outside. So here's a picture of him on the ground. Here's a picture of the being launched. As he got near the ground, he used his parachute. Here he is inside the capsule. Anybody know who this guy is? Nobody knows, huh? You remember the name Jaeger? Mr. Gallagher, did I hear you say that? Good, thanks. Thanks, Eric. Pardon? He did. He did. Did you read that in the... He did. 833 miles an hour. He's the only human to ever break the sound barrier by himself in this free fall. Nothing happened to him. Just like nothing happened to the plane that Yeager was in when it went through the sound barrier. Did you read the caption out there? Hold on a second. Read the caption. $85,000 of helium. At that altitude, you can see the curvature of the Earth, can't you? This is an altitude of 20 miles. 20 miles is how high? There he is on the beginning of his jump. The highest free fall ever. And in order to avoid the bends, you guys know what the bends are? Okay. Nitrogen in your blood, because nitrogen bubbles form in your blood because nitrogen is how much of the atmosphere? What percent?
72%.
Huh? 78%. Jesus, would you like to have a little wager on whether it's your 72 or my 78? Maybe I like that shirt. Maybe I'll wager your shirt. You. Okay, calm down. This is just before launch, and because of how high that portion of the balloon is, you remember the balloon goes all the way down to here. This is just a tether line connected to it, so it had to have a crane operator keep the canopy off the ground until the balloon went up high enough to be able to let it go, and it would swing back this way. And as it continues to go up, it gets bigger and bigger. I don't know. Anybody know what that is? That's right, the Bell X1. You had good eyesight. Maybe not a good memory, but good eyesight. Oh, here he is, about ready to jump. I guess you have to be pretty gutsy to do that, don't you? So that's the double eagle, and that's the double eagle. This is a short little.
This episode is sponsored by Dropbox. If it sometimes feels like the whole world is pressing in on you, well, that's because it is. A 1 square meter column of air above your head stretching from here to the edge of Earth's atmosphere contains almost 10 tons of air. That's a lot to carry on your shoulders. But if it ever feels like too much, you know what's a great way to get away from it all? Balloons! That's not what I meant, guys. Not like that. Like this. Balloons are magical. Birds and planes stay aloft by using power to keep air moving over their wings.
We fill blimps and party balloons with lighter gases like helium, but balloons like those weigh thousands of pounds. And they're not filled with helium. They're filled with the very same air they're floating in, yet they still go up. Now that you mention it, why does the atmosphere itself stay up?
That column of air above your head we talked about earlier, well, it's the same mass as a couple of elephants. But just like elephants, air molecules obey gravity, and I don't see any floating pachyderms around. Think about it. Air is mostly empty space. If I was an oxygen molecule, I'd have to travel the length of a football field on average before I ran into another one. But occasionally, they do collide. Air molecules will fall until the collision's bouncing them up. The pressure is balanced by the weight pushing down on them. Up high in the atmosphere, there's not much air on top of us and not much colliding going on, so the pressure's pretty low. But down a little lower, we have a big mass of air above squishing down, so things get more crowded and the pressure is higher. This sets up a gradient all the way down to Earth. The lower we go, the air's more crowded. It takes more collisions to balance out all that squishing. Even though it's mostly empty space, air can still hold up a plane. I can sit in a chair in the sky riding on almost nothing and not fall to the ground. That is crazy.
You may have heard that the Wright brothers are responsible for humans taking flight, but that's wrong. 120 years before them, in 1783, the Montgolfier brothers had the brilliant and kind of dangerous idea to light a fire underneath a cloth balloon, and humankind took to the skies for the first time. Heat is what is keeping this balloon up. You probably heard your whole life that hot air rises, but have you ever really stopped to ask yourself why? I mean, well, you know what? We're going to need a smaller balloon to figure this one out.
Ah, that's better. This is the ideal gas law, and it tells us pretty much everything we need to know about how gases behave. Pressure is basically the force over a given area on a surface. Whether a balloon inflates depends on the difference in pressure inside and out. As we heat up air in a balloon, the molecules gain kinetic energy and start colliding with more force on the inside surface. The pressure goes up. As the balloon expands, that force is spread across a larger surface area, which lowers the inner pressure until the pressure on both sides is the same, or until it pops. But this balloon isn't made out of rubber. It's pretty rigid. Once it fills up, it can't really get bigger. But it does have one thing that the rubber balloon doesn't. A hole in the bottom.
You know what the mass of air in the balloon envelope
This
is?
is 105,000 cubic feet.
We can calculate that a little bit.
That's the matter. That's 105,000. I don't know.
Well, I calculated it. When we first filled up this balloon on the ground, it held about 3,700 kilograms of air. Add in the basket, the fuel, the people, and of course the balloon itself, and that's another 500 kilograms or so. A lot of mass to lift. But then we added some
As we're adding heat to this balloon, those air molecules are moving around faster and faster with more energy, and they're pushing on the balloon harder and harder. But the volume has remained the same. It hasn't gotten any bigger or smaller. The pressure's pretty much the same too. The balloon's not collapsing or popping. So that only leaves us with one other option. There must be less air in that balloon than when we were down on the ground. Hot air has leaked out the bottom. We're still being pulled down by gravity, but the equal volume of cold air around us weighs more, and it's falling down underneath us. Balloons don't defy gravity, they float because of gravity.
Eureka! This is the principle of buoyancy that Archimedes noticed when he saw his bathtub rise. It's the reason that ships float, because the weight they hold is less than the weight they displace, and the water falls down around them. We know that buoyancy is due to gravity because bubbles rise here on Earth, and they don't rise on the space station.
You said that flying in a balloon was like what?
Flying in a hot air balloon is the closest thing to being a cloud that I can think of. We're just floating with the wind, as gentle as can be.
Flying in a hot air balloon kind of reminds me that we have something in common with fish, that we live in a fluid. It's just that ours is made of air instead of water. It's kind of like floating on a bubble. That's something that can lift all our spirits. Stay curious.
Okay, well, I'm sure that those of you who were watching the video will have taken notes, because I'm sure that there will be at least 3 questions on the quiz where the information was in the video and wasn't elsewhere. So if you paid attention, you're lucky, and if you didn't pay attention, probably not going to be able to answer those questions. Let me see how long this...
The cost of housing in California can be a backbreaker if you're like me living on a fixed income. Watch out. Prop 10 will drive up rents, make housing less affordable and less available. That's why seniors say no on 10.
We'll watch a little bit of it, but not much. Are they using the Are they using the burners? No, why? It would melt the balloon, wouldn't it? Now they are.
Oh, it is taking off. Can you read a video of this? Yeah.
And when the balloon comes down, that's what happens to the basket. It tips over and gets dragged along the ground if there's any kind of breeze at all.
Oh, we gotta get in. Yeah. Yeah.
Wait, can I tell you to come over?
Okay.
Holy shit.
That noise of that propane burner is so loud you can hear it from miles away.
The largest wintertime rally in the Southwest. It's going to be a big one. I mean, they're really great over there. Great hospitality. It's a great place to fly. It's a lot of fun. Yeah, it's a good event. Really good event. Forcing it, into the soil to let it percolate through and into the aquifer. That spot, the sunshine spot to go up on those hillsides, the mountains to the right there. We're gonna be tickling the bottom of these clouds as we go over these hills. Right now we're moving at 18 miles an hour. We're tracking almost due north, which is great. We were averaging about 12 miles an hour most of the hillside and to the valley floor over there.
Oh, look at that!
Fist and rah. But it started to have a lot of accidents, fatal accidents. It was a big deal, and it was just destroying balloon during the air. You have to wait too long.
Anyway, ballooning is only fun for about the first couple minutes, and then after that you start worrying about